Hello and welcome to the Section 2.2 lecture. Today we're going to start working with scientific notation, which is really just a way to deal with very large or very small numbers. Okay, when we start talking about like distances in our solar system, those numbers are so large that we can use different units that cover more of an area. It's probably easier to talk about distances in our solar system with say miles rather than inches or feet. But even at some point we might want ways to write even bigger numbers without coming up with more units, because the more weird things you come up with as units, as far as like you could talk about light years or something like that, people don't really understand what that really looks like because they've never dealt with those. Whereas most people know how far a mile is. So even when we start talking about those bigger numbers, we might want ways to sort of minimize the values so that we can write it a little bit easier. So that's where scientific notation comes into play. Scientific notation is when you write something in scientific notation, it's usually written with a number that's between 1 and 10. So you have a number like 4.5, and you're going to multiply that by a power of 10, say 10 to the 5th. So this number is always between 1 and 10. And this number, and we always have multiplication, and this is the rare time, even at higher level math, that this multiplication symbol is used. Really we're kind of moving towards using a dot for multiplication, but even in scientific notation at the higher levels, this is usually used as an X. And this is always a 10. The two things that can change are the number before the multiplication and the exponent. So it kind of fits in with our exponent work that we've started with, and that's why it's covered here. So we have some weights of different sea life. We have a blue whale, a gray whale, and a whale shark. To put the weight of the blue whale into something a little bit more manageable, we want to turn this 250,000 into a number between 1 and 10. So what do you get when you find a number between 1 and 10 out of the digits used for 250,000? We want to move the decimal point as far left as we can to give us that number. We're actually going to move the decimal point between the 2 and the 5. So we get 2.5. Now, one way that you can figure out how far you moved it is to take our 250,000 and divide that by 2.5. A calculator is probably the best to do that. And what you get when you do that is you're going to get 100,000. Okay, we can't leave our answer as 2.5 because it's definitely the weight of the blue whale is definitely not 2.5 pounds. We have to find another way to say basically what we're saying is 2.5 10,000s. Okay, if you had 10,000 and you do that 2.5 times, that's going to give you the weight of that blue whale. They also want us to write this as a power of 10. The way that we write powers of 10 is basically to count the number of zeros that you have. I have 1, 2, 3, 4, 5 zeros. So this is going to be 10 to the 5th power. Okay. And then we combine our answers to say that 250,000 is really just 2.5 times 10 to the 5th power. Okay. The next one, they want us to represent the whale shark in scientific notation. The whale shark's weight is 41,200. And so I want to do that same thing. I want to move the decimal until I get a number between 1 and 10. Well, if I move it once, I get 4,120. If I move it twice, I get 41.2. Or sorry, 412. Move it 3 times, I get 41.2, which is still bigger than 10, so that doesn't work. I have to move it all the way between the 4 and the 1, so I get 4.12. That's a number between 1 and 10. Now we got to figure out how many times did I move it. If I go 41,200 divided by 4.12, I'm going to get 10,000. Which, if I count the zeros, that's 10 to the 4th. Okay? So I combine those, 4.12 times 10 to the 4th. You might be asking yourself, how do we know that the whale shark's weight ends in 2 zeros? How do we know that it's a perfect 200 after that 41,000? And it kind of comes down to the fact that we don't really. It probably doesn't. But in science, they take much more of a serious stance on rounding numbers to give you significant digits. So that's where this really comes from. It's probably not 41,200, but it rounds to 41,200. So we just have to know that those other digits are what we call, relatively insignificant. For as big of a weight as that is, those other digits don't really matter. The tens and ones there don't really make that much of a difference when you're dealing in the 40,000s. Okay. So the reflection questions here: how many places to the left did you move the decimal point to write 41,200 in scientific notation? We moved it 4 times. Basically, to turn this number into a number between 1 and 10, I moved it 1, 2, 3, 4 times to put it between the 4 and the 1. And so that relates to what is the exponent on 10 when you write it in scientific notation? It's 4 again. And that's because we moved the decimal four times. Okay. So, in writing a number in scientific notation, we want to talk about writing large quantities. We'll talk about writing small quantities next time. Okay, these are all very big numbers. Okay, when the number is greater than or equal to 10, a number like 84,000, we want to use a positive exponent. So our 4 here is going to be positive. We don't really have anything to base this on or judge this on because we haven't talked about when it's a negative. Okay, so we're just talking about, we haven't talked about when we have a negative exponent. So we'll get to that next time. So let's look at this example that they do for us. It says that the distance from the Earth to the Sun is about 93 million miles. And we do have systems in place for a lot of things that we could just say 93 million. But even with that, sometimes people misunderstand what that means or don't really understand the size of that. So we want to give an accurate representation of what that's going to look like. So again, we move the decimal to give us a number between 1 and 10, so we get 9.3. And again, they look at the division of 93 million divided by 9.3. and we get this 10 million. So again, this is basically like saying the Earth is 9.3 10 millions of miles away from the sun. Okay? And so then we write that as 9.3 times 10 to the 7th, because there's 7 zeros here. Let's take this opportunity to try a couple problems. I have 6,400. I want to move the decimal to be between the 6 and the 4. So that takes moving it once, twice, 3 times. So since I move it 3 times, that's going to tell me it's 10 to the 3. I'm not happy with how that looks. That's not a whole lot better, but that's okay. 10 to the 3rd power. So my answer here is going to be 6.4 times 10 to the 3rd power. Okay. Here I want to move the decimal between the 5 and the 7. And when you have a big enough number and you have commas in place, you can use those commas to your advantage. Instead of counting every one, for a little bit I'm going to count by 3s. I move it 3 times, 6 times, 9 times, and then 10, 11 times. So I moved it 11 spaces. So I'm going to have 5.7 times 10 to the 11th power. So here we go, we're talking about light years. In this one, a light year is the distance light travels in a year, and it's equivalent to a lot of kilometers. I think that's about 9 trillion kilometers in a year. We want to write that in scientific notation. So again, I'm going to look at this decimal that originally lives over here is going to move 3, 6, 9, 12 times. So that's 12 moves of the decimal. So that's 9.461 times 10 to the 12th. Okay. Now I'm going to take a quick pause here, and just to make sure that people are watching the videos and actually listening to the videos, I'm going to put in a code word. I'm going to do this for every video from here on, just to get us in that habit of making sure that we're listening and not just watching. So kind of the first question on the reflection that you'll have, or it's either going to be the first question or the last one, I don't know. Somewhere in there is going to be a question that asks for what is the code word. I'm not going to write the code word, but you might have better success if you write the code word right here. The code word for today's lesson is going to be apple. I'll say that again. The code word is apple. All right. Again, if I wrote it, that just wouldn't make sense. You would be able to see it, and then you still wouldn't have to actually listen to the video. Just a little trick that I picked up. So now we're going to work on writing numbers in standard notation. Standard notation is what you usually see where it isn't being multiplied by 10 to some power, it's just the number itself. Okay? So in this first problem here, we want to write 3.5 times 10 to the 6th power. We want to write that in standard notation. It's in scientific, and we want to switch it into standard. So we're going to use the exponent on the power of 10 to tell us how many spaces we have to move the decimal point. Okay. Since that exponent is a 6, we want to move the decimal 6 spaces. All right. I'm going to show you how I do that because it doesn't always look this pretty. The book has, the advantage that they're using. They're using a typing system to do this, so it looks really nice. Mine never looks that good. I want to move this decimal that's right here. I want to move it 6 spaces. And the key here is that this is a positive 6. I know we haven't talked about negative exponents in scientific notation yet, but we will next time. So I'm going to say it here. I'll probably repeat it then. Since this 6 is positive, this is actually a really big number. Okay? Takes a little bit of memorization. I'm going to move it 6 spaces to make a big number. 1, 2, 3, 4, 5, 6. And in every one of these gaps, I have to fill in zeros. And so when I'm answering this, even when I'm answering in a book, or on paper, I should say, it never looks great when I do that, right? I wouldn't like to just leave that as my answer. So I kind of, look at it and say, well, there would be a comma here, and there would be a comma here. So we're left with 3,500,000. And there we go. So they want us to explain why the exponent in 3.5 times 10 to the 6th is 6, while there are only 5 zeros in our final answer. So why is that? Why are there only 5 zeros, but I had to move the decimal 6 times? What I'll say for that is to move the decimal six times. We have to move it once. We have to move it once to pass the 5. Then we move it 5 more times. So then we move it 5 more times, giving 5 zeros. Okay. So this one is an entirely different problem. And it's asking us to write 5.3 in scientific notation. So let's remember our rules for that. We want a number between 1 and 10. Well, 5.3 is between 1 and 10. So scientific notation on 5.3, and then we want to say 10 to the power of the number of times we moved the decimal. How many times did we move that decimal? We didn't move it any times. It started as 5.3, and now we want to write it as 5.3 times 10 to some power. So how many times did I move the decimal? 0 times. So it's going to be 5.3 times 10 to the 0. And that's kind of given us a new rule of exponents that, I think it's a new rule. I don't think we went over it. But anything to the 0 power is 1. Okay? And so our exponent is 0 there. Let's get done with these couple of your turn problems, and then we'll call it a day. So I want to write the number 7.034 times 10 to the 9th. So I write 7.034. Again, I kind of write it off to the side somewhere because I know this isn't going to be my final answer. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I have to fill in all those zeros. There we go. And then it might help to put some commas in there so I know what I'm looking at. And I have 7.034, 3 zeros, and 3 zeros. And there we go. 2.36 times 10 to the 5th, so I'll move it 5 times. 1, 2, 3, 4, 5. There are other ways that you could do this. You could know that I have to move it 2 times to get past the 6, and then how many times are left? 3 more times. That's another way to do it. But what I get here is 236,000. Next one says the mass of one roosting colony of monarch butterflies in Mexico was estimated at 5 times 10 to the 6 grams. We want to write that in standard notation. Same idea. 5. The decimal's after the 5. And I want to move it 6 times. 1, 2, 3, 4, 5, 6. Maybe put in some commas. Gives us 5 million. Alright, hopefully that helped. Hopefully that makes sense. If you have any questions, make sure that you write them down, and we'll try to answer them next time we meet. Until then, have a good day, and we'll see you in class.